What is up guys, this is Pyhome's Tutorial at welcome back sa ating channel. Sa video ito pag-uusapan naman natin ano nga ba ang plastic centroid sa concrete column. So what is plastic centroid? Plastic centroid is the location of the resultant force produced by the steel and the concrete. For example, meron tayo ditong concrete column reinforced with 8 RSBs. Of course, this is column. And primarily, columns are compressed. Now, say for example, this is the elevation view of this column. Because this column is being compressed, there will be a reaction by the concrete. Tawagin natin itong C sub C. And similarly, all the steel bars also react because of the compression force. Tawagin naman natin itong mga C sub S. We have here 4 C sub S because we have 4 layers of steel bars. Similarly, we have here the C sub CS. Ito naman yung kapag tinanggal natin yung ating mga RSB, magkakaroon ng butas itong ating concrete column. And dahil butas ito, gawin nating pababa yung kanyang direksyon to indicate na magmaminus ito. And finally, yung net or yung resultant ng mga forces na to ay tawagin nating C sub T. This is now the location of the plastic centroid. Also, we have what we call the geometric centroid. This is the location of the centroid of the concrete column without the reinforcement. Simply, gawin lang natin tong parang shape. Now, the concept we're going to use here is the Varignon's theorem or the moment area theorem. That is equal to area total x bar is equal to summation of the areas times their x bar or their moment arm. Now, kailan nagiging equal ang location ng plastic centroid at ng geometric centroid? When the column dimension and rebar arrangements are symmetrical, the plastic centroid and the geometric centroid will coincide. For example, dito sa ating concrete column, we have here a rectangular with 8 rebars. The 8 rebars here are actually symmetrical. If we have here an X and then Y axis plane on the center, we have 4 on the left and 4 rebars on the right. Similarly, we have 4 rebars on the top and 4 rebars at the bottom. So the rebar arrangement are actually similar. And the rectangle is also similar one. So for this example, the plastic centroid is actually equal to the geometric centroid. Now, this is the formula for locating the plastic centroid. The total force times its moment arm, the x sub p, or the location of the plastic centroid, is actually equal to the summation of all the forces acting with their moment arm x bar. Very similar to the geometric centroid. For geometric centroid, we use area because it is geometry. For the plastic centroid naman, we use forces. Now, these are the parameters we have put in here. We have C sub C as the compressive force of the concrete, the C sub S, the compressive force of steel, C sub T as the total compressive force, X sub P, the plastic centroid, and then C sub CS, the compressive force of concrete occupied by the steel. Okay, next we try to imagine. We remove the rebars from our concrete column. Say for example, this is now our elevation for this plan view. We notice now that our concrete column here is being hollowed. Now because this concrete column is being compressed, of course the concrete reacts with C sub C force. Similarly, all of our rebars act C sub S. Then, finally, all the hollow section has C sub S reaction. This is again to indicate that this is hollow section, therefore we need to subtract all the forces acting there. Now we derive formulas for these forces, C sub C, C sub S, and then C sub CS by using the pressure formula, which is equal to force divided by area. Now this C here are actually forces. Therefore, we equate force equal to pressure times area. Now, for the concrete, this is our force, and then we denote the force of the concrete to be C sub C. And the pressure acting for the concrete, by our code, it is stated that it is only 85% of the compressive force of a concrete. That is 0.85 F prime C. Now area is simply the area of the concrete with a subscript of C here. Now for the holes, which is also a concrete occupied by the steel. Now we call this C sub CS. Again, this is concrete simply occupied by the steel. Therefore, the pressure must be 0.85 F prime C steel times the area is now area of the steel, because this hollow here is actually occupied by the steel before. Then for the steel, we have here C sub S is equal to the pressure acting for the steel is simply the yield stress Fy times of course the area AS. Now this is for approximate calculation only. We have an exact calculation for the steel. This is actually what we call the C sub S net. This is the steel minus the holes. So, bawasan na natin. Okay, bawasan na natin dati yung pressure or forces na nangyayari dito sa ating concrete. Dahil yung steel, inoccupy niya naman yung mga butas na to kanina, dito na lang natin gawan ng formula. C sub S net is actually the steel na pataas minus the occupied by the steel, which is yung holes. Then we substitute the formula for the steel and the holes. We have here Fy times AS minus 0.85 F prime C AS. Now we can actually simplify this one like this. Labas natin yung AS, then multiply quantity Fy minus 0.85 F prime C. Then finally, for the total forces, we have the total forces is simply C sub T equal to the summation of the C sub C plus the C sub S net. Hindi na natin kailangan pa ilagay yung holes at saka yung steel na to. Dahil itong steel na to ay ito yung approximate. Gagamitin natin dapat ay yung exact. And yung holes naman, nandito na yan kanina. Minus na natin. Kaya finally, ang ating formula for the total forces is simply the concrete plus the steel net. Okay, let's have this example number 1. We have here a T column with dimensions 400 by 300, then 200 by 250 on the other side. This is the main bar. The bigger subscript B is 25 mm. Then the smaller one, or the stirrups or the ties, is 10 mm. The F prime C is 21 megapascal, Fy is 420 megapascal, and the concrete cover is also given by 50 mm. Now determine the location of the geometric centroid from the 400 mm side and the location of the plastic centroid from the 400 mm side. This is our solution. First, the location of the geometric centroid from the 400 mm side. Again, by definition of geometric centroid, we don't need the reinforcement. So, we remove the reinforcement and consider only the dimension of the concrete. Like this. Now, we locate this location of the geometric centroid. We call this the X bar. Then say for example, we divide this by two areas. For the 400 and 300, we call this the area 1, and the 200 by 250, we call it the area 2. Now the area 1 is simply 400 by 300, that is equal to 120,000 mm square. For the area 2, we have 250 by 250, or 200 by 250, which is equal to 50,000 mm square. Then for the total area, that is A1 plus A2, which is actually equal to 170,000 mm square. Now going back to the variance theorem, that is area total x bar is equal to summation of all the areas with their x bar. Again, we are asked what is the location of the geometric centroid from the 400 mm side. Therefore, all our reference must be from this 400 mm side. The total area, we already have 170,000. Area 1 is actually 300 divided by 2 from the 400 mm side, and area 2 is actually 300 plus half of 100 from the 400 mm side. We rewrite this one. For the area total, that is 170,000 with the x bar is equal to area 1, 120,000 times the moment arm, or the dimension of the centroid of the area 1 is actually half of the 300 mm side, plus 50,000 for the area 2, multiply that by the moment arm, 300 for this first side, plus half of the 200. And then finally we have the location for the geometric centroid is equal to x bar equal to 223.53 mm. Next, for the location of the plastic centroid, again from the 400 mm side. Okay, we need the rebars here. Okay, so for this figure, I already remove all the stirrups because we don't need it anyway. So the concrete cover is given 50 mm, diameter of the main bar is 25, diameter of the smaller bar or the ties is 10 mm, F prime is 21, then Fy is 420. Say for example, this is the elevation view of this column. So we have here 3 layers of rebars. Again, if this is being compressed, we have reaction from the concrete and of course reaction from the steel. Now, we have separated these two areas here. We have here the bigger rectangle that is now acted by the C sub C1, and then the smaller rectangle here is acted by the C sub C2. Then also we have 3 forces for the steel bars. That is C sub S1 net, C sub S2 net, then C sub S3 net. This is already net, meaning we have already subtracted here the holes. Okay, so we locate first the dimensions or the moment arms of these rebars from the 400 mm side. So for the C sub S1, we denote it X bar 1, for the C sub S2, X bar 2, and for the C sub S3, X bar 3. Now what is X sub 1, X bar 1, X bar 2, and X bar 3? For X bar 1, that is equal to, first, the concrete cover. That is 50 mm plus, we have here 10 mm. This is actually the tie diameter. Why? Because meron ditong nakaharang na ties muna. Ang 50 mm ay mula sa edge papunta sa edge nung ties natin. So yun yung 50 mm plus diameter nung ties 10 mm plus of course half netong ating main bar, that is 25 divided by 2. Then finally we have X bar 1 equal to 72.5 mm. Now for the X bar 2 naman, so ano naman yung location nitong rebars natin dito from the 400 mm side? Mahirap kapag kukunin natin starting from this side papunta dito sa gitna nito. Pero pwede natin gamitin yung 300 mm dito. That is 300 mm Paatras naman tayo. Cover dito na 50 mm. By the way, itong concrete cover, all throughout na yan ng side ng ating column ay 50 mm dapat. So, yung 300 mm, bawasan natin ng 50 mm. And then again, meron naman ditong ties ulit. So, minus 10 ulit tayo dito. And then, again, minus half of this main bars. And finally, we have X bar 2 equal to 227.5 mm. Then lastly, for the X bar 3, we have, again, similar step to the X bar 2. But this time, gamitin natin na length ay yung 300 plus the 200. So that is 500. Then, paano natin minus kanina lahat? Ganun lang din dito. Minus 50 for the concrete cover, minus 10 for the ties, then half of this main bar. Then finally, we have X bar 3 equal to 427.5 mm. Now, pwede na natin kunin. Ano nga ba yung mga forces natin? Unahin natin yung concrete forces. That is the C sub C1 and the C sub C2. The formula again for C sub C is equal to 0.85 F prime C times the area of the concrete. Again, hinati natin to sa dalawa. Meron tayo ditong area 1 and area 2. Now, yung area 1 natin again, kanina ay 120,000 mm square. So, equate lang natin dito. C sub C1 is actually equal to 0.85. The F prime C is 21 megapascal times the area of the concrete 1, that is A1, that is 120,000 mm square. Now, we divide it by 1,000 to make it kilonewton. Okay? So, finally, we have 2142 kilonewton. Then, similarly, for the C sub 2 naman, again, ito naman yung area natin for the C sub 2. That is 50,000 mm square. So, therefore, C sub 2 is 0.85, 21 times 50,000. Divide again by 1,000 to make it kilonewton. Therefore, we have 892.5 kilonewton. Now, ito na yung mga concrete forces natin, yung mga C sub C. Next, we get the C sub S net forces. Okay, the steel forces, which is net, are, for the C sub S net, we have the formula AS times quantity, Fy less 0.85 F prime C. Now, unahin natin yung C sub S1 natin. Again, for the C sub S1, we actually have here 4 steel bars on this layer. Kaya, dapat meron tayo ditong multiplier na 4. The area of the steel is pi over 4, 25 square. Multiply by 4 dahil we have 4 steel bars in this layer. Okay? And then Fy natin is 420 minus 0.85 F prime C. Again, ang makukuha natin dito ay Newton. Kaya divide natin ng 1,000 to make it kilonewton. So therefore, we have 789.62 kilonewton. Next, for the C sub S, CS2 net. For the C sub S2 net, we also have 4 main bars here. Magkamukha rin, 25 mm parehas. Kaya, ang C sub S2 ay simply equal to the C sub S1, which is also equal to 789.62 kilonewton. Then finally, for the C sub S3 net, we have, now this time ang multiplier na lang natin ay 3 dahil meron lang tayo ditong tatlong bakal. 3 pi over 4, 25 mm square times 420 minus 0.85, 21 divided by 1,000 to make it kilonewton. Finally, we have 592.21 kilonewton. Then again, for the total forces, this is simply summation of the concrete plus the steel net. Okay? Then, the C sub T is finally equal to, for the C sub C, we have C sub C1 and C sub C2. That is 2142 plus 892.5 plus, for the steel, we have 789.62 multiplied that by 2 dahil dalawa naman, plus 592.21 kilonewton. Then finally, our resultant force is actually equal to 5,205.95 kilonewton. Then, if we rewrite everything here, ito na yung mga C sub S1 natin, C sub S2, C sub S3, C sub C1, C sub C2. Ito na rin yung mga dimensions or distances. X bar 1, 72.5, X bar 2, 227.5, and then X bar 3, 427.5. Then ito naman yung ating plan view. Then say for example, somewhere here yung ating plastic centroid. Again, to locate the plastic centroid, that is C sub T times the plastic centroid equal to the summation of the forces with their distance from the reference, 400 mm side. Okay? And then finally, we equate. Again, this is the total forces, 5,205.95 X bar P equal to, unahin na natin itong 789.62. 789.62 times its moment arm, 72.5. Again, from this 400 mm side. So, ito yung magiging reference natin on this side. Next, the 789.62 times its moment arm na 227.5. Then next, 592.21 times the moment arm, 427.5 mm. Next, for the concrete, the C sub C1, that is 2142. Multiply that by, of course, half of this 300. Yun yung kanyang distance from the 400 mm side. Then next, or the last one, is 892.5. Multiply that by 300 plus half of this 200. Para dito sa ating concrete 2. Yun yung kanyang moment arm. Then, simplify everything. We get the location of the plastic centroid equal to 224.43. Alright, see you sa next video para naman doon sa ating eccentrically loaded column. Thank you and God bless.